Okay, so today we're going to start with lesson 1-1, and so what we may be adding to our notes is that nomenclature, so you can figure out where you need to go. So chapter 1, lesson 1, that's what the 1-1 stands for. And the title we're going to put to our notes is the title that is on that lesson, which is variables and expressions. This is going to be on the even side, so the right side. Today's date is getting closer to, October. We're at the 28th today.
It's getting closer to literally everything.
Okay, yes it is. Very, second by second, day by day. We're getting closer. So we're going to start our notes today with front-loading you with a whole bunch of information, vocabulary words in particular. That way, you know exactly what I'm talking about. So here's what's going to need to happen. That circle is going to need to go onto that page. In addition to, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8 vocab words. Some of them are as much words as they are labeling, so you understand what I'm calling something, okay? So, because all of these things show up on homework tonight. So number 1 vocab word is going to be algebraic expressions. So again, remember that circle's got to go on that page.
Which side does this go on?
All your notes go on the right. That circle's going to go on the right. So an algebraic expression means, what is it missing? It's missing an equal sign. So it's just numbers, operations, and if we use the word algebra, what has to be part of that expression? What makes algebra algebra? Michael, I heard you. I saw you mouth it. Variables. Nope. So algebraic expressions, they have numbers, operations, variables. So the key is what Lainey told us. No equal sign. Bless you. The reason why that's important is these we're not solving for the variable. These we're going to be told the values of the variable, and then we're going to do math. Okay? So that leads us to our next word, which is the word variables. Oh my goodness, bless you. So it's a letter used to represent an unknown in a problem. So remember, we're still going to need to glue that circle onto that page. Keep that in mind as you're writing down your definitions. Okay, and you can use any letter. People tend to use X a lot. Certain letters are not the greatest. For example, T, because it looks like a plus sign the way that you draw it. So you have to be kind of cautious with that. Okay. Term. That's our next one. A term is a number. A number. A variable. Or a product or quotient of numbers and variables. Seems to be side conversations. Notice what's excluded in the definition of a term. What was something that was mentioned in algebraic expression that's not mentioned as a term? Nico? Okay, well, that's mentioned in there. I said something important, because these are all expressions, so we're not talking about anything else. Jay? Yeah. So this particular one there's no operation symbols. So I'm going to give you an example. Let's say we have 2x plus 4. 2x and 4 are terms. The plus is nothing. Okay? So it's not part of what a term is. So it's the actual values. Now, let's see if anybody knows there's a better word that we use for term. We'll be using it a little bit later. Starts with the letter M. Lots of syllables. Anybody know what I'm talking about? Mike? Michael? Nope. Bless you. Monomial. Yeah. Yeah, that's it. Whoa, yeah, you read my mind, says Lainey. You read my mind. Okay, yeah, We be moving. Next. What are factors? Factors are the values being multiplied. So this only works for multiplication when we talk about factors. So I'll give an example. Let's see, how do I want to do? We'll do it this way.
Are we doing the circle on the page?
No, on the right side. Yep. That's why I said you guys had to kind of keep that in mind. So x, y, x, and y are factors. Okay. Now, the answer to a multiplication product is called what? Product. Okay. So the answer to a multiplication problem is a product. All right, now the last one I'm going to put is I'm going to draw you a picture, and then we're going to label the pieces. Okay. So again, this should be nothing new, Johnny Ray. This should be all familiar. You guys should have seen all of these things before. So the last guy I want to put in is this. Okay. Well, I want it to not look like a multiplication symbol, so it's somewhat italic-y. Okay. So, does anyone know what we call that whole thing together? That whole thing together. When you were a kid, you might have watched a show about the Rangers.
Power Rangers.
So this is called a power. Okay. What is the big X called?
Oh, I know it.
Okay, think about when we were looking at triangles and the formula, we talked about one of the sides that makes up the formula for the area of a triangle. And this one's located at the generally bottom. Jenny?
The base?
He's called the base. And then the guy up at top, he's got a name. I heard it. Exponent. Yeah, no stealing thunder today. So when we're talking about things to power, a power, we're talking about a base number that is being raised to an exponent. So we would read this as x to the nth power, because I don't know what value it is. So basically what it's saying is take x and multiply it by itself n times. So x times x times x times x until I have n of them. And then we get an answer. So we're going to be dabbling with all of these things on our notes today. Okay, so for a moment, we're going to cut over to the odd page, and we're going to do just a little bit. Oh, no, I don't want to do that yet. We're going to go back. We'll go to the circle now. You want actually it to be down there, so if you want to trim it a little bit to make it fit. You're going to pick out 4 colors. You're going to use one for each section we've created. Okay. So what we're going to do is talk about the plus symbol. So what we're looking for is words that tell us to add. And we're going to fill in that part of the wheel. So what are some words that tell us to add? So, good. What's another? Patrick. That's a add symbol, and now we're putting words that mean add. All right, we could be here all day. You guys are not in the mood. I'm just going to tell you. All together. We have all together. We have plus. We don't hear that one as much. The most common one is things like more than and its friends. We're going to talk about more than again in just a moment. Probably the most important thing I want you to have is when we talk about adding, we need to understand that it's inverse of, come on you, of subtraction. Okay. Because we're going to be talking about equations a little bit later and how when we solve equations we need to understand inverse operations. Go ahead. Let's go to words that tell us subtraction. So yes, subtraction. Oh, I forgot one good word over here. The answer to an addition problem is called a sum. Okay. So the answer to a subtraction problem is called a difference. And we have minus. We don't hear that one as much. Takeaway. That's really old. Let's see. Obviously subtraction. I'm not going to put that on there. This one, less than. And we're going to talk about less than in a little bit as well. And this is also, subtraction is the inverse of addition. So let's talk about words that tell us to multiply. Obviously, we've got multiply. We've got product is the answer to a multiplication problem. Times, that's the one we hear most often now. Let's see. Of, when you think of that percent proportion, how many, what percent of 32 is 16? So of is a multiplication word. And then we have a couple of special multiplication words. We've got twice, and that tells us to multiply by 2. Okay, that's very common. And we can write that it's the inverse of division. And then we have division. So the answer to a division problem is called a quotient. Q-U-O. Yeah, that doesn't look good. I'll try that again. Q-U-O-T-I-E-N-T, quotient. Per, when you have ratios or rates, those are per, is the fraction bar. Ratio is another giveaway. Divided by. Divided into. I'm going to talk about that one a little bit more. And division is the inverse of multiplication. So when we want to undo something that has division, we're going to do it with multiplication. Okay? So what you're going to do is find some space around the outer edges. We're going to add 3 more things in 3 different locations. Okay? So first location, I want you to write equals. Equals. It's on the outside of the circle now. Words like is, are, were, gives, totals. So action word is the word that we interpret to mean equals. Okay? So those are just some examples of words that tell us to write equal sign. Is probably the most common one. Then we're going to have parenthesis words. Parentheses words. And put parentheses around them. These are phrases that tell us that phrase needs to be put parentheses around. Because what's going on in that expression is that there's multiple operations. And so you need to kind of put parentheses. So most common ones, the difference of, the sum of, okay. There could be operations in front of them like times, or could be quotient, or lots of different things, okay? Now probably the most important one is this last group, and we're going to call these switcher phrases. When I am taking a phrase, or when I'm taking English and I'm trying to change it into a math expression or sentence, I need to pretty much translate it literally. Now, how many of you are taking Spanish? A couple people? Okay, so in Spanish, they do an order differently than we do. Like if I'm talking about the White House, I say the White House. So my description comes before my noun. But in Spanish, they say la Casa Blanca. They say the house white. So their description comes after the noun. So what these switcher phrases do is they take the numbers that are on either side of the switcher phrase, but you write them in the opposite direction that they were written. So what came last goes first, what came first goes last. Okay? So we'll do some practicing with that. So switcher phrases that end with than. So I'm going to just put a blank. Oops, let me go back to blue. Switcher phrase is something than. So remember we talked about more than. We talked about less than. switcher phrases that end with from. That would actually be a subtraction one. I could add that. Subtracted from. I'm going to abbreviate subtracted from. That would be considered a switcher phrase, because you're taking a number from a different number. We have into. That would be that divided into. We really don't have any switcher phrases for products, for multiplication. It's just mainly adding, subtracting, and then there is division. Okay. Let's see. There's another one I've seen. We'll come across it. Okay. So our job now is let's practice some of these things that you're going to be doing on homework tonight. So is everybody done? So on our odd page, this is where we're practicing. Some of you are still having trouble remembering even and odd, because I don't think all of you have numbered your pages in your spiral yet, so you've got to do that. So here's the first set of directions, similar to what you might see on your homework. Write a verbal expression.
Should we write this down?
Yes. What I write, you write. For each algebraic expression. So we know an algebraic expression is like a math, almost like a phrase, because it doesn't have an equal sign. So it can't be described as a sentence. So we're going to see numbers, we're going to see variables, we're going to see operations. Verbal means in words. So we're going to write out in words what we see. So 3x to the 4th power. It's hard for me to even you can't read it. 3x exponent 4. So when we read this, we need to include the operations that are going on. So we would say 3 times x to the 4th power. So on your homework, you got to make sure if you have problems like this, you write down the original problem, and then you tell me in words what it stands for. Does that make sense? So copy this one. That's a z. How do you think what would we write in words for that expression with the 5, the z, the 2, the plus, the 16? Nico?
5 times z to the 2nd power plus 16.
Okay, good. And I might change one little thing. 2nd power actually has another name.
Times 2
Squared. So I would probably do the little bit more sophisticated of 5 times z squared plus 16. Oh. Okay. And I think I might actually change 5 to a number or a word as well. That was cheesy on my part. But I liked how Nico did not forget about you got to say times. Okay. All right, let's do one more. This is the tricky one. I have a half, I have an A, I have a plus, I have a 6B, I have a fraction bar, I have a 7. That's not how you would read that, obviously. So, who thinks they can read that one? Michael, give it a shot.
1/2 times a plus 6 divided by b over 7.
I don't think I agree with that last part. I think something happened. Patrick.
1/2 times a plus 6b divided by 7.
Okay. All right. That could work. Perry?
1/2 times A plus 6 times B over divided by 7.
Okay. All right. I'm going to give you, I want to use one more word that you guys haven't used. Okay? I think the last three sounded really good. Now, I am going to throw in some words. Something that you guys didn't use off of the chart. So, 1/2 of A. You guys all told me times, which is appropriate, but of is a lot more common what people would say. Plus, and here's something else I didn't hear anyone say, the quotient of. Six times B and 7. Now, the reason why I wanted to kind of point out this is because when you're told you have a quotient, what goes in the numerator versus what goes in the denominator gets separated by this guy, the word and. For some reason, people think and means plus, but no, it's a separator between pieces. The product of 7 and 3b, that's telling you these two things you're going to multiply. Okay, so that's something else to watch out for, is and doesn't mean add all the time. Sometimes it does. Okay, so that's one part of what you're going to see. Now we're going to go the other direction. Everybody good? Can I switch? Because I'm out of room. So we're still on that same page, but now the directions, so we're on the odd page, still writing down examples. So we've got write in algebraic expression for each verbal expression. Okay. So we're on example 4. So this one's, we get to write out a number t, and notice we never did that. We always went right on and just used the letter. So we can say the number more than 6. So how would I write an algebraic expression for this particular problem? Algebraic expression for this one. Okay, I've got some of the usual suspects. So I'm going to call on peace. What does more than tell us? Okay, it does tell us add, but did more than show up someplace else in our notes? Where did more than show up? Something than. A switcher, okay? So keeping that in mind, what would you write, knowing that more than means yes to add, but it also tells me to switch? Okay, so that's what we have to kind of watch out for. Now, there is a property that says 6 plus t and t plus 6 are exactly the same, and that's fine. However, if it was a subtraction problem and you didn't switch the order with the than, you would have the answer wrong. So if we just get in the habit, every time we see the more than, we switch the order, I think we're going to be better off. Does that make sense? Okay, so let's try one more. 10 less than, speaking of which, the product of 7 and f. So how would I write 10 less than the product of 7 and f? Jackie.
7f.
Wow, no hesitation. Good job. So the less than was the giveaway of the switching. So again, this is telling you to switch. The and says group those two together. In the math, it tells you which was product. Okay. So that's what we're watching out for when we're doing this. Okay. I've got one more. And this is kind of a scenario. So let's see. Katie bakes 40 pastries. You have to write this, sorry. And makes coffee for 200 people. Write an algebraic expression for this situation. So Katie bakes 40 pastries and makes coffee for 200 people, excuse me. Write it in an algebraic expression for this situation. So Savannah, what's missing in this problem?
She doesn't really tell us like what she really needs. Like it only really says that she baked 40 pastries and she makes coffee for 200 people. It doesn't really tell us like we need to add them or we need to.
Well, think about it. If you're making pastries and coffee for people, what math are you doing? Are you subtracting pastries and coffee? Are you multiplying pastries and coffee? Are you dividing pastries and coffee? Are you adding pastries and coffee? Yeah, we're doing two different tasks, and we're putting it together. Okay? Now, what is missing that we need in order to write an algebraic expression? We've got a couple things that are missing. Okay? Joey? Okay. Well, we know there's 200 people. Okay. Well, at least 200 people for coffee. That's what it says. Patrick? Yeah, it didn't mention any variables. So this is when we have to choose our variables and define them. So what would be a logical variable for pastries? P. P is the number of pastries. And we're also missing one for coffee. So what would be the logical one for coffee? C. Or actually, we need to just say pastries, not number of. We're going to add that in there. Because remember, I cannot include words when I'm doing algebraic expressions. Okay, so P is going to stand for pastry, C is going to stand for coffee. According to what this says, I have some numbers that now get involved and operations. So let's see, Kelly. How would I write this algebraic expression representing what Katie did? Dang, dead on. That's it. That's all we would do. Okay, and that's the end of notes.